Thanks everyone for coming. I know there are lots of talks you could be seeing at any given moment. You definitely made the right choice. This is a talk you should come to. So this is a talk about TDD, and it'll make the most sense if you've already been practicing TDD for a little while. So I'd like to get a show of hands. Who here has attempted TDD at one point in their life? Great. Now, who here has done TDD for a year? Okay. Who's done it for 3 years? Okay. 5 years? 10 years? Okay, so Joe Moore is the only person with his hand raised anymore. He was the guy that, you know, stood on stage and bragged about how he's pair programmed for 30,000 hours. All right, so this talk is called TDD, the bad parts. And I really do want to talk about some problems with TDD, but I also like this name because I'm pretty sure it's half the reason all these people came to this room. It's a provocative title. I work for Pivotal. So it may sound odd that somebody from Pivotal is talking about bad things that go along with TDD. But actually, you know, TDD is a practice, and like any other practice, there's pros and cons. There's trade-offs, and there's things we've learned along the way about how to manage this practice. So anyways, yeah, I want to tell you a cautionary tale. I started at Pivotal about 4.5 years ago. I'd been doing TDD for about a couple of years at that point, so I'd learned it at a previous job, to some extent anyways. And then I came to Pivotal and I worked with all these amazing, passionate people. They're really good at doing TDD, and I learned a lot from them very quickly. And I want to tell you a story about one of the first projects that I was ever on. Okay, so there was a startup founder that had an idea. This idea was beautiful. It was a really good idea. And the startup founder didn't know anything about building software. And that's okay, because they had money. And they were able to use that money to go hire an agency. They found a little boutique shop to start building the software for them. They did have somebody that they knew that told them, like, hey, if you're going to go build software, make sure you're building it with people who do agile software development. That way you'll get to see demos and stuff like that, and you'll be able to react to it and kind of change the product as you go. And this was like, great, okay, let's do that. So they found this boutique agency, and they went to them, and that agency assigned a developer to the project, and they built something very quickly. The startup founder got this demo, was really impressed by it, like it came so quickly, gave them feedback on it, and they started working to tweak it. And they were like, great, let's just sit back, let the demos roll in, we'll give the feedback. Pretty soon, we're going to be super successful. But then the demos started happening less and less frequently. You know, at first it was every week or so, and there was a lot of changes that would happen in between each of those demos. And then it slowed down, and it seemed like it'd be every few weeks before they'd finally get something. And the amount of change in between each demonstration was less and less over time, right? So what was going on? It was confusing. This went on for about a year, and eventually the startup founder said, okay, I have another idea. I still have money, and I'm going to go talk to these people called Pivotal Labs. Because they might be able to help me, and they'd gotten a recommendation from somebody, and they did. And we came in and said, "Sure, let's help you figure out what's been going wrong and see if we can help you course correct." So we got access to the codebase, and we started running the tests because this agency had actually built tests for the software. And so great, let's see what happens. So we started running the tests, and they were running. Minutes went by, several minutes, and then about an hour went by, and they were still running. And they just kept running and running and running and running. And it was 6 o'clock, and we were like, okay, it's time to go home. What do we do? Right? It's still running on this development workstation. So we just went home. Like, I don't know what could go wrong. So we came in the next day, and the computer had caught on fire. It had not actually caught on fire, but it did run out of memory. It totally crashed. This computer just ran out of memory. We're like, ooh, that's really bad. So we were able to actually quickly, almost miraculously, figure out what the memory leak problem was. It was actually something very trivial. We fixed it, and then we were able to rerun the test suite. And the same kind of thing happened, right? It took a long time to run. We got to the end of the day. We're like, it's still going. Let's cross our fingers. We came in the next day. The test suite had finished. But this is what it looked like. It was mostly red. Very, very few passing tests. Mostly red. Not what you want. This had been going on for a year. They had built this test suite that had thousands of failing tests that took over a day to run. What went wrong? It just blew my mind when I saw this. Okay, we'll come back to this story at the end of the talk. The next thing I want to do, before we can talk about some of the things that went wrong, we have to make sure we're clear on why we do TDD in the first place, because it helps us understand what about TDD practices are good and bad and what we can do about them. So at Pivotal Labs, we've been doing TDD for a long time now. Our founder, Rob Mee, started doing it with Kent Beck back in the late 90s and turned our Pivotal Labs consulting company into one of the first extreme programming consulting companies out there. And so for at least about 20 years now, we've been actively practicing TDD and kind of honing that craft. But we don't do it just because, right? Just because Rob said. We do it because it's been proven over time. But what is it actually enabling us to do? So our goal is not TDD. TDD is more like a means to an end. The actual end that we want is to go fast forever. We want to enable software teams that can start day one building software rapidly, put it in front of users, get feedback, take that feedback, do something with it, adjust the software, put it back in front of users over and over and over and over and over again, and do that indefinitely. We don't want to see what happened to this client ever happen for one of our teams. The one thing you need if you're going to go fast forever is clean code. Because bad code will slow developers down. Who here has been slowed down by bad code before? Everyone, right? You've all been slowed down by bad code. It doesn't matter how good you are, right? Put the best engineers in the world on a code base with bad code and they won't go very fast. In fact, if they're really good engineers, they'll go even slower than others because they'll spend a lot of time cleaning it up, right? At least at first, right? But that's okay. So if you want to go fast forever, you have to have clean code. And how do we do that? Well, cleaning your code is like, taking a bath. It's something you don't just do once, right? It's something you do continuously. You're always doing it. It's like daily hygiene, right? You do that through this process called refactoring. Yeah. Who here practices refactoring? Okay, cool. This is a good audience. Refactoring is the process of keeping your code clean at any given time, saying, okay, I'm going to hold the behavior constant. I'm just going to make sure it keeps doing what it currently does, but I want to fix the code, right? The code is kind of messy in these certain places. Let's go clean it up. That's a process of refactoring. So the real question is, why don't more teams refactor their code? Why don't they always keep their code clean? That's because a lot of teams become afraid. They become afraid of what might happen if they change the code in certain ways. They're not quite sure if everything will still work, right? So if you're going to refactor your code continuously, you need confidence. You need a lot of confidence, actually, that all the changes you are making are still resulting in working software that you can put back in front of users. Sadly, there's no like magic button you can press to get that confidence. And shipping your software to a QA team to manually run a bunch of QA tests, right, is not a great way of getting that confidence because it takes so long, right, to get that feedback, right? That's a super slow feedback loop. We want a super fast feedback loop. So the way you do that is by writing tests, right? This is the real reason you write tests, because you want the confidence to refactor your code to keep it clean and go fast forever. And it's actually, if everything depends on tests, right? All this stuff eventually depends on tests. That tells you when you should do it. It's the most important thing. So that's why you do it first. That's why you do TDD, right? Test-driven development is the process of first creating the test and then writing the production code. So anyways, that's why we do TDD at Pivotal. And that's what we help our clients understand. All right, so let's start talking about some problems that we've run into and seen in the wild. So a first problem is outside-in BDD. Who here practices outside-in BDD? Yeah, it's cool. It's not actually a problem, but if misapplied, it's pretty problematic. So let me just show you an example of what that might look like. It often starts with first write a failing feature test, right? This would be like an acceptance test that tests the system as a black box, right, from the outside looking in, and pokes and prods it in certain ways, and then sees whether or not it spits out certain things, right, and puts the application into some kind of new state. And then maybe from there you start diving lower and writing lower level tests, right? And those start failing. And maybe they lead you to write another lower level test. And eventually you get to the bottom, right? And at the bottom of the stack, you finally get a test to pass. And then you start working your way back up the stack. So even though it only looks like kind of 2 circles here, it's actually a lot of circles often. Sometimes when you see teams try to apply BDD, they'll do something like this. They'll first write an acceptance test that we just talked about, and they'll be like, great, it doesn't work. So now let's go write our controller test. Great, that doesn't work. Now let's go write our model tests, right? And maybe they're database models that they're interacting with. Okay, now we got those working. Now let's go back up. Let's get the controller test working. Now let's go back up and let's make sure the acceptance test works. And they do this over and over and over and over again. And so when you look at the test suites that they've created, one thing that almost you can always observe is that these test suites are slow. And they get slower and slower and slower over time. They often are very brittle in such that if you make one change to the test over here, lots of different things start breaking, right? And you feel like you have to kind of massage a bunch of stuff together just to keep it all working at the same time. When you look at the code bases, the actual production code, not the test suite, they're often very tightly coupled, right? It's often that the high-level policy and the low-level detail are all like mushed together and stuff like that, and everything's hyper-integrated, which makes it hard to maintain that code base over time. The test suites often are flaky too, right? That over-rely on this kind of acceptance testing. You know, like a flaky test, if you don't know, is a test that passes 1 second and fails the next, and then passes again the next second, right? It's just like intermittently read for bad reasons, not for actual real reasons. There's this thing called a testing pyramid, and a classic kind of ideal that many teams try to strive for with the testing pyramid is that you have very few kind of high-level feature tests kind of at the top of this pyramid, maybe a slightly larger number of sort of acceptance tests or somewhere in between tests that do integrate a few things together, and then a large number of unit tests, right, that comprise the bulk of your test suite and the bulk of where you get your confidence from. But when you see teams misapply BDD, they often end up with testing pyramids that look like this. Almost everything is tested through the browser or through the simulator, or whatever kind of system they're trying to build. And they have very few actual unit tests. So there's this idea that has, I guess the real question has become sort of, what does outside mean? And then who here has heard of Cucumber? Cucumber, yeah, a lot of people have heard of that. So one of the early and kind of influential builders of Cucumber, this guy named Joseph Wilk, he noticed this problem at some point, and he said that it's a shame that people have conflated outside with GUI, right, or outside with user interface. Because what they actually meant was outside-in behavior-driven development means start at the outside of what you want to discover, right? And it's not often the user interface that needs discovery, right? Often that's much more well understood. It's more the business rules, right, that you need to tease out and you need to actually work through, because anyone who's done software development for very long knows that it's in the doing of the work you discover the work that must be done, right? And so as you get in there and you start actually trying to express this logic and these business rules, and you have this back and forth with your product managers and your business analysts and people kind of outside your team and your users, right? That's when you discover all the interesting stuff. All the stuff that's unique is your domain. So I think one important takeaway is don't necessarily conflate outside with GUI. That doesn't mean it's never the GUI that you want to start at, but it shouldn't be the default. Okay. There's almost an opposite problem that we've seen sometimes. So some teams exhibit the first problem where they've misapplied outside-in BDD. Other teams exhibit another problem where they've misapplied mocking. Who here knows what mocking means? Yeah, okay, perfect. Okay, let's look at this bit of code here. If you've done some Spring, this should be really obvious, right? Like we're inside some kind of controller. We have a show method here, and imagine that you have some translation service that translates incoming words into Pig Latin. Okay, all right, so we have a very simple method here that basically just says whatever the string is, make it the response body. Teams that have misapplied mocking might create tests that look like this, right? They start by creating a mock translation service, and then they mock methods on that translation service, and then they spin up the controller and they use mock MVC to test that, and then they run the post actually on the mock MVC and expect that what the response that they get ends up becoming that thing that they mocked out, right? And teams that have misapplied mocking kind of or cranked up that knob too far, you'll see this at all levels of their testing, right? They're like, wherever we are, let's just mock everything out. And on the one hand, their tests are incredibly fast, right? And that's cool. That's really cool. But on the other hand, their tests are almost entirely meaningless, right? They don't actually test behavior. They test implementation. And if the implementation needs to change, even though it wouldn't necessarily change the behavior, the tests start breaking, right? Anytime you're in a situation where your tests break, even though the behavior hasn't changed, all you've done is refactor the implementation, you're witnessing coupling. Okay, so I'm not trying to say that mocking is wrong. Mocking is totally a thing that we need to do at various times. And there's actually all kinds of different mocks that we have to educate ourselves about. Mock is actually a slang word, by the way. The real name for all of these are test doubles. And there's 5 types. There's dummies and stubs and spies and mocks and fakes. Stubs are a type of dummy and spies are a type of stub. Mocks are a type of spy, and then fakes are something completely different. You have to know what these are and before you can even start to figure out, like, when would I use some of them? If you don't know what they are, start by reading this blog post that Uncle Bob wrote. It's really concise. It's a super concise blog post that will very quickly give you the information you need to understand what all of these different test doubles are. And it'll start to give you some pointers around when you might start to use them. But if you really want to dive into when you need to start using them, you have to understand the dependency inversion principle and the other solid principles too. So if you don't know what solid is, right, it's a series of design principles that we can adhere to when we're building code to help us create maintainable code. And they apply regardless of whether you're building object-oriented software or whether you're using a functional language. These are design principles that are paradigm agnostic. So if you don't know what those are, feel free to check out cleancoders.com. There's videos on there, a whole video series about these principles. Or if you like to read books, there's a great book called Agile Software Development, Principles, Patterns, and Practices. You can work with Pivotal Labs, because we know this stuff, and we'll pair with you on it, and we'll just do it. Another thing you could check out is the screencast series that I created. This is a shameless plug. It's called Hexagonal TDD, and there's only 3 screencasts, and they're all pretty short. So you can watch those too, and it'll introduce you to some of these concepts and talk about when you would use these test doubles, how you use them at boundaries of your system, at the boundaries of a component within your system, how you start to think about the components of your system. So anyways, misapplying mocking often happens because there's not only a misunderstanding of what mocks are, and a misunderstanding of what all the different types of mocks are, but there's also a misunderstanding of when they're appropriate and when they're not. Sorry. Okay. Problem number 3, unit testing. Who here does unit testing? Yeah, unit testing is my favorite. Unit testing in and of itself is not a problem, but the misapplication of it is. So let's talk about the 3 laws of TDD. Who knows these laws already? Okay, this will be good. So the first law is you are not allowed to write any production code unless it is to make a failing unit test pass. Okay. The second law is you are not allowed to write any more of a unit test than is sufficient to fail. Not compiling is failing as well. And 3, you are not allowed to write any more production code than is sufficient to make the one failing unit to pass the one failing unit test. Okay, right? That locks you into this sort of very fast cycle of TDD, right? Maybe a 30-second to minute long cycle where you're constantly writing a little bit of a test, watching it fail, writing a little bit of production code, making it pass, refactoring, getting it all kind of cleaned up, and lather, rinse, repeat. Around and around and around you can go in that cycle. It's a really good thing. These 3 laws of TDD are fantastic. However, over time, they have been, I think, extrapolated into something that is less useful. So There are a lot of people out there that practice TDD that would believe the statement to be true and would tell other people that this is TDD. Every class should be paired with a well-designed unit test. And some take it even further and say every public method of every class should be paired with a well-designed unit test. And so this is really the problem. This leads to this very problematic misapplication of unit testing. You know, and what that might look like is literally every single public method of every single class gets a test, right? And you end up with class 1.java has a class 1 test, class 2.java has a class 2 test, and then maybe you decide you need to refactor some of class 1, right? And you're going to use the design pattern underneath the hood in the implementation. So you're going to hold the behavior constant, but you're going to refactor the implementation. People that conform to this kind of misunderstanding of TDD will not only refactor the implementation, they'll change the tests, right? So they'll go back and start moving the tests around to be like, well, I guess I need to make a new test class over here for this new class I created, even though the behavior isn't really changing, because I'm supposed to make sure that every single class and every single public method of every single class has a well-designed unit test for it. The problem that you run into with this is coupling. It's not the kind of coupling that we were seeing with mocking. It's a different kind of coupling. It's a coupling in which your tests become aware of the design patterns you are using underneath the hood in your code base, right? And the design patterns you didn't decide up front. You refactored into those design patterns. But now by coupling your tests to those design patterns, you have made it harder to refactor away from those design patterns when the time comes. Because there will be a time when those design patterns no longer apply, and you need to use a different design pattern. Right? When your test stepped away from, I'm just going to test behavior, to, I'm going to know about every single class and every single public method of every single class, you put yourself in a position where you're making it harder to refactor your code and keep it clean, right? And so what happens when you do that? Well, refactoring becomes harder, your code does not stay clean, and you stop going fast forever. So instead of saying every class should be paired with a well-designed unit test, what if instead we said every behavior should be paired with a well-designed unit test? That would allow us to minimize the surface area of our test suite, right? We would be very intentional about what our test suite interacted with, right? What are the boundaries of this component that we're testing? What are the entry points that our test suite will exercise? And then how do we allow the stuff inside those boundaries to evolve over time? How do we allow ourselves to refactor it with impunity without having to change the tests, right? And that's really the goal, and that's how you go fast forever. So, this company still exists today. They weren't destroyed, but they were so close to being destroyed by code. In fact, they were very close to being killed by TDD. So all I'm really asking you to do is not kill your companies with TDD. Instead, deliver on the promise of TDD by actively honing the craft and actively reflecting on what's working and what's not, and talk with other people in your community and in your company and constantly adjust it. And think about some of these kind of misunderstandings that we've built up over time in some of our communities. So anyways, thank you. I think I still have 8 minutes for questions. So if anybody wants to ask a question now, that'd be great. Otherwise, we can talk outside.
A lot of organizations build test coverage into KPIs. There is not necessarily a one-to-one correlation between behavioral coverage and test coverage for those KPIs. They recommend addressing that problem we're talking about.
So the question is, a lot of organizations build test coverage as part of their KPIs, and they measure teams on how much test coverage there is. And you know, I've seen that both work well, and I've seen that also be disastrous, right? Like, it is easy to make test coverage 100% without actually testing anything useful, right? And depending on what kind of organization you have, and depending on how the incentives work out in that organization, you might find that the developers do the wrong thing to game that system. That being said, I've also seen it applied quite well and effectively, right? There are other organizations where there was a belief and a buy-in that, yes, we should be practicing TDD. And if we just start practicing TDD, this number will change over time. And we're just going to measure that and monitor that and keep track of that. I think, well, I don't know, that's not really an answer, but it is possible to use test coverage effectively. And teams that do TDD will end up with very high amounts of test coverage. It may not be 100%. It's great if it can be, right? But maybe there are things that kind of the cost of testing it versus the actual benefit of getting a test around that doesn't pay off. And so when you put teams in a position where they're effective enough and mature enough to be able to understand and make that kind of trade-off, right? That's when you know you're winning. Yeah.
I was floored by your information and receipts when I took the last.
Awesome. Yeah, totally. So, in fact, in one of those links, there you go. In that one, if you go here, there's not only a screencast series in which we actively build code to, I think, more effectively practice TDD and design the code base, but there's also code you can access on GitHub as well that go along with it. And we can talk afterwards too. There's another open source code base I could point you to as well that might be helpful. Yeah.
Do you have any standards or like expectations on when you implement contract integration tests?
Yes, the answer is yes. Sorry, the question, I'm sorry, I'm supposed to repeat the questions for the video. The question is, do we have standards on when we implement integration tests or contract tests? So let me be clear on what I'm going to mean by the definitions of those terms. Contract tests, I typically use for a collaborator that I'm going to inject at a boundary, and yet which I know I'm dictating some very well defined set of expectations about the behavior of anyone pretending to be that collaborator, right? And so maybe that collaborator is a fake in-memory repository that I happen to use in the test, right, to test this other component over here. Or maybe that collaborator is a real persistence layer, right, that actually integrates with a database or sends data across the wire to a microservice, right? Like there could be all kinds of different implementations of that collaborator, and yet they all have the same behavioral contract. Right. In fact, if you watch this, you can see the process of making a contract like that and then implementing it both for a fake and a real implementation of the thing. And I think that will do a better job maybe of explaining how I think about that than I could right now at this moment. The other interesting thing, and this is an observation that Dan North is the creator of BDD, or at least he coined that term many years ago. He's a fantastic speaker. He gave a really great talk at CraftConf called Microservices, Software That Fits in Your Head. I highly recommend watching this talk. It's slightly sneaky in that he's not actually talking about microservices, but he makes this fantastic observation that when you start building components, like these loosely coupled components, right, and you start designing these modular systems in the way potentially described in this and the way you'll see in some other things, that all these different types of testing that we talk about, right? Like contract testing, integration testing, acceptance testing, feature testing, unit testing, right? Like they all disappear and they all collapse into one type of testing, component testing. It's this really amazing observation that he had where he talks about how as we mature the way we think about and design our software and our systems, it's simplifying our process of testing software. And the cognitive burden that we built up over time and trying to figure out how to test poorly designed software. Any other questions? Yeah?
I think one of the reasons why there is coupling between test and production class is that IDEs make it really easy to navigate from one to another. However, if you break this coupling, what's the practical trick, I guess, you use maybe to simplify this navigation?
Can you talk, are you talking about like in an IDE where you're in a class and you type make tests and it generates a test for you for that class? Yeah, totally. And you can switch back and forth. Yeah, that is fantastic. That's super convenient. IDEs like IntelliJ, all the JetBrains IDEs do this for pretty much any of the languages. When you don't have that, when you have these set of behavioral tests that don't necessarily map one-to-one to a specific object, but maybe it maps to this method over here, which may underneath the hood use a series of objects and a design pattern to satisfy the behavior. You do run into the situation where you're like, what is this testing? Or you may be in the production code and you may say like, I wonder what tests this.
That's typical situation. Like
yeah.
You came to existing code,
yeah.
you want to change behavior.
Yeah.
Yeah,
which test covers this?
Exactly.
Yeah, that's great. That's a great question. The easiest way to figure that out is break one of the lines of code in the production code and run the tests and see which test breaks. It totally works. Like if somebody's actually been doing TDD properly, right? Like you will find that broken test really quickly, right? And if they've been doing it well too, it won't take that long to figure it out because they have this really fast, effective test suite. And if they've been doing it well, you're only inside a single component, so all you need to run are the tests for that component. Yes, any other questions? Okay, cool. We're out of time anyway, so thank you.